Hello everyone. In this video, we will learn how to find arc length of a polar curve. Well, everything will boil down to the fact that for a parametric curve, so if you have a parametric curve, x is given in terms of a parameter, y is given in terms of the same parameter on the interval AB, the arc length, the formula for arc length was given by this. So you integrate from A to B, square root of derivative of x with respect to t, derivative of y with respect to t, square those, add them, find square root, and dt. So now I want to use this formula when we have a polar curve. For a polar curve, so remember that we are considering the cases like this. We can turn this into parametric curve by considering that, well, x is r cosine theta, y is r sine theta. Since r is given as function of theta, I can replace it and write x completely in terms of theta and y in terms of theta. And let's say we are considering theta going from A to B. Now, the parameter here is theta, and we want to find dx d theta, square it. We want to find dy d theta, square it, and add them, then find the square root. Let's just go ahead and do this one. Derivative of x with respect to theta. Use product rule. Derivative of cosine is negative sine, and that's the derivative of x. Derivative of y with respect to theta is going to be f prime theta sine theta plus f theta. Derivative of sine is just cosine theta. Let us expand these two terms. So the first one is going to be f prime theta squared cosine squared minus 2 times the first one times second one. So here I will write f prime times f, and then cosine theta sine theta. And then the last one squared, which will be f theta squared sine squared theta. That is just expansion of this term. How about the second term? So this will go in a very similar way. So we will find sine squared theta. Here will be 2 f prime theta, f theta, sine theta, cosine theta. Plus the last term squared is this. Now, there are good simplifications here. You see, this and that are the same terms with negative sign, so they will cancel. And when I look at the first term of each one of these guys, I can factor out f prime theta squared. Then the remaining will be cosine squared plus sine squared theta. Plus, I do the same thing for the last two terms. So if factor out f squared, then there will be sine squared theta plus cosine squared theta. Well, sine squared plus cosine squared, we know that are 1. So what we found is that this guy is going to be the function itself squared plus the derivative of the function squared. So now we can write this as a fact, a theorem, or a formula that you can use. The arc length of polar curve r equals to f theta for theta between a and b. This is equal, given by this integral, a to b of square root of f theta squared plus derivative of f squared d theta. Well, sometimes you will see, since f theta is r, you will see in the book or people writing this as r squared plus dr d theta squared d theta. Okay? So that is the formula that you have to have in mind when you're trying to find arc length of a polar curve. Let's just use it in some examples. We have cardioid 1 plus sine theta. So if you start to sketching this thing, at theta equal to 0, it is 1. At theta equal to pi over 2 is 2. Then it goes back to that and this. So this is something like, I'm trying to make it nice and as nice as I can. Okay, good. So here now, what are the angles? So we start from 0 and we go up to 2 pi, yes? Or you can use symmetries. So instead of going from 0 to 2 pi, we can go from this to that. While 3 pi over 2, if you write to pi over 2, will be a little bit strange. Instead of 3 pi over 2, you can write negative pi over 2. So using the symmetries here, I can write this guy, symmetries, as 2 of negative pi over 2 pi over 2 root of r squared plus dr d theta squared d theta. Now, I can go ahead and plug in all the values or all the functions there. So this will be r squared is 1 plus sine theta squared plus the derivative is just cosine theta squared and then d theta. This is 2 negative pi over 2 pi over 2. This is, well, expand this guy. 1 plus 2 sine theta plus sine squared theta plus cosine squared theta d theta. Well, these two will add up to 1. So what we have here is root 2 plus 2 sine theta d theta. This integral, okay, let me factor out root 2. So I want to get it to the simplest form so I can show you how to integrate this guy. Well, this is not easy, at least in the first glance. You have to do some work there, yes? The trick here we need to use is this. If I multiply both numerator and denominator by the conjugate of this guy. The reason we are doing this is that when we multiply in the numerator, we will get in the numerator, we get 1 plus sine theta times 1 minus sine theta will be 1 minus sine squared theta over 1 minus sine theta. Yes? And 1 minus sine theta is cosine squared. So cosine squared theta square root over 1 minus sine theta d theta. So square root of cosine squared is absolute value of cosine theta. But when you look at this guy from negative pi over 2 and pi over 2, this is same as cosine theta itself. So this is one of the reasons that I choose that sub-interval. If we have started from 0 to 2 pi, we had to consider this absolute value and separate integral into two pieces where cosine is positive, where it is negative, and go ahead and do that integral. But now that we have this means that I have very nice integral. Just pause the video here and try to evaluate it from this point on yourself. For me, when I do look at this guy, I notice that the derivative of inside the square root is basically up there. Well, I'm missing a negative sign, which is not a big deal because I can multiply everything by negative and then go, this is the u 1 over u, and well, see that if theta is negative pi over 2, then u is going to be sine of negative pi over 2 is negative 1. 1 minus negative 1 is 2. And for theta pi over 2, u is 0. So we go from 2 to 0. Oh, sorry, this should be square root. And that tells me now I am dealing with very simple function. 2 root u, go from 2 to 0. And when you plug in those values, the first one is 0, the second one is 2 root 2. And when we multiply those guys, this is going to be 4 times root 2 times root 2. It's just 2, then 8. The arc length of this cardioid we calculated is equal to 8. So this was the formula that you have to know, and we did an example there so that you see what is the how to do an example for the arc length of polar curves.